Hello, everyone, and welcome to the Waku Vibe coding session. I am Chair. I'm here to prop you up. With me is Waku Solutions Engineer Václav. Hello, sir.
Hello, Chair. Hello, ladies and gentlemen on the stream.
Thank you for joining me today. Václav, excited to get into it. Folks that are tuned in now, wherever you might be, and most likely it's X, you can please like, retweet, and share this broadcast. That would help a lot. Without further ado, I'll pass it over to Václav, who will be taking you through your journey today. Thank you very much, sir.
Yes, I will. Thank you, Chair. Let's see where this journey actually takes us, because there is no clear path and no clear end of the journey. So I tried to figure out what I want to do. I had it pretty well figured out, but I didn't have time to do the preparation that I was gonna do. So this is as much learning for me as it's gonna be for you. And if you know more about Miden than I do, then please let us know in the comments, and we can pick your brain during the live stream. If it looks complete dumb, it may be that I am dumb, or I I'm I don't know. I don't know what to say. I don't even know what to say. So, what is the goal for today? Today, I want to hack something with Waku and Miden. So, I know Waku pretty well, so I think I can hack something with Waku. But I don't know Miden a lot. So, Polygon Miden, I don't know if it's an official name still, Polygon Miden, or if it's just Miden now. But it's a privacy preserving blockchain where one feature of Miden is that you can do completely private off-chain transactions, basically. And what that means in context of Miden is that you generate this zero knowledge node, which contains all the information for the transaction to be executed. And then you get it to the recipient of the funds, or recipient, or like whoever has to execute a transaction. So instead of executing the transaction on chain, you basically execute it off chain in the other person's wallet, and then you both of you push kind of a proof that it has been executed on chain. And so this is pretty cool. I think it's an extremely cool idea, an extremely cool way of doing things. It has one caveat: you need to get some information, the node content, from one account, one wallet to another. And we believe that Waku is a good way to do it. And the reason for that is that if you want to do it, if you are trying to use a privacy blockchain, you do not want to use some centralized server which could potentially track what you're doing, who you're sending, what, and all that stuff. So you want to use some privacy preserving infra for that. So Waku makes sense there. If we can integrate it into a dApp or into a wallet in a way where I can generate this node, and then over Waku I can send it to the other person. So maybe I want to send Chair 100,000 million billion tokens of this amazing meme coin on Miden. And so I just need to know his address and maybe some other identifier for encryption, or we can
You don't have to
negotiate it
send me
somehow.
that many. Just 1%
And
of the total supply would be great. Thank you.
yeah, I mean that's what I said basically. Yeah, it's a lot. It's a high supply, but basically, yeah. Then just like let the node travel over Waku, and then Chair can execute it, and we just both commit on chain that it has been done. I'm sorry, I'm a bit distracted. There are people running in front of my window here. Sorry. Okay, so here is the documentation for stuff. I have it opened here. They have a like Miden is implemented in Rust, the core libraries and the blockchain. So they obviously have a Rust SDK, but they also have a JavaScript SDK for building front ends or web apps, right? So that's what I'm gonna use, because then I can use JS Waku, and it should be pretty straightforward. Now, the second part of the story is that someone has already built a proof of concept UI for Miden. I actually started with that last week, and then I realized, or someone pinged me that, hey, this is already there. I'm like, amazing. Then I don't have to do all that work. So you can go to this URL. We can also share it. I have it here. It is pretty straightforward. So let's go through it. Let's take a look at how it looks like. So I'm just gonna go to my terminal here and make it bigger. So I think that I have everything installed. pnpm install up to date. Everything is up to date. npm run dev. And then it should start running on 3000. So let me just reload here. Because I was obviously trying these things before the live stream to not look like a complete stupid person. Okay, so now this is the front end, and it's pretty simple. It's pretty straightforward. So we have basically three main sections: account management, which is where we manage wallets. I was trying to clean this up. Why is it still here? Let me just refresh. Why is it the deployed account still here? Maybe there is a local storage still somewhere here. Trollbox, Eliza, deployed accounts. Oops. Deployed accounts, deployed faucets. Let's clean it up completely, just so that we have a clean slate here. So we have account management. As you can see, I have no account here. So what I can do, I can create this account, maybe test live stream. I'm going to make it a public account. I'm just going to hit deploy. Now it says deploying account, and it failed. Why did it fail? Right. So I've noticed this thing, and it is supposed to be fixed now, but it's either because this has an old version of Miden SDK, or because some other things. Basically, they have a testnet RPC, and that testnet RPC fails with course policy. So what I have done here is that I am somewhere here. No, here. I am running a local Miden node. So everything I do is not going to be on a public Miden testnet blockchain. It's going to be local on my kind of a local network, which is fine for experimentation. But I have to do some changes here. So this is the code of the POC UI. So we need to find locations where there is an endpoint. So let me just, I don't know what's going on. Let me just open it again, because I was cleaning the repo a bit, and I think it just crapped itself. Okay, so you can see that there is a node endpoint here, and we will need to make it HTTP 000 dot and the port. Yeah, and the port is, let me just stop this blockchain here. So the port is here. Copy. Let's start the node again. And that port is this one.
Can you
And
zoom in
if
one
I'm not
level more?
mistaken,
Like, yeah.
this one? I can. I won't be able to type much here because it's just tiny, but we'll see. I think there was some constants where it was redefined here as well. Yeah, so let's maybe clean it up. So let's remove this one. And this is gonna fail, and we just need to import it. And then it should be good. So now when we reload this, just to be sure that we have everything loaded the way it should be, we have no account, test, live stream, deploying. Now it should be talking to my own node. And as you can see, it deployed an account, and I have account ID, which basically looks like a normal address. So there is a second part of it, and it's portfolio. So once you have some assets, so maybe we mint some tokens, and then they will show up here. And then we have this last part, which is kind of a tabs for different kinds of operations. So we have address book. So if you want to send someone, this is my address. I can add new contact, and I can have it here in the send part. There are nodes. So the nodes I mentioned, so there are two types of nodes, private and public. So if we send a public transaction, it will go on chain, and then it will show up immediately on the other person's UI as a consumable node once they refresh this. And then there is faucet, and the faucet is basically kind of like you can create your own tokens and mint them and then transfer them around. So this is the way to test things out. So I'm just gonna go here and select this test live stream. I'm gonna do symbol WAC as in Waku. Total supply is what 1 million tokens, 8 decimals, and deploy faucet, and that should hopefully work. Fingers crossed.
It's definitely going to work.
I mean, definitely is a strong word in case of this experiment, but maybe it will. Should be talking to my local node and generating some zero knowledge stuff, proofs, and things like that, which usually takes a bit of time. I don't think that there are any errors. Some
Folks,
warnings,
as
but no
we
errors.
wait for this to succeed, I would implore you to please like and share this stream wherever you might be watching. Most of you are on X. Follow Waku. Follow Václav. If you have questions, please drop them in the chat wherever you might be watching. We can see them.
Yeah, and this is taking weirdly long, so maybe you jinxed it, Chair. With your, this will definitely work.
I just
Okay,
sped
let's
along the debugging process.
Yeah, I mean, just let's leave it spinning. So let's take a look maybe at the code. So how this is just a standard Next.js application. So there are a bunch of components. We have seen those components on the UI, and then there is this library part where basically we have seen the constants, which is just the node endpoint. Utils is to basically build the node content based on some input data, some helper function. And then there is this Miden client, which is to initialize the Miden SDK. The Miden SDK is built in Rust, and then through WebAssembly, it gets into the browser. So this is basically just to make sure that it only initializes once, because if it happens twice, like with a lot of time with Next.js and React, it re-renders, and if it's not handled properly, it will try to initialize things twice. And the WebAssembly SDK does not like that at all. And then there are some helper functions just basically making sure that we are executing this on client side, because this is a Next.js application. So some of the code may get executed on the server if there is a server. And so they are ensuring that this client stuff is actually executed on the client side, and then making sure that everything is initialized before we actually call any function on that web client module. And now we have a bunch of things here: batch transfer, get account, basically mostly helper functions to get the UI filled with data. Let me check if we progressed here. Actually, we did. Okay, so that's great. So let me finish running through this. So now here is a web client, and this is the kind of a meat of interacting with Miden client here. So we get the client, and then we basically talk to it. So there is usually a get account. The account ID is the address that you have seen there. And so we need to get the account. And if we have an account configured, we can do stuff with it. And here, for example, we are trying to get the assets. And so we need to get the account itself. And then we need to take peek into the account and find the fungible assets, the tokens in there, and then map it to some structure so that we can display it. We can create a transfer, which basically means we can create a multiple or an array of nodes. Every node has sender and recipient, and then the token that is being sent and how much of the token, and then whether it's private or public. Now, if it's public, then basically that information, that node itself goes directly on chain, and then the recipient can fetch it from the chain. If it's private, as I explained, it has to get to the recipient in some other way, right? And then we build a transaction. So if it's public, and then more data goes on chain. If it's private, then just the proofs should go on chain, as far as I understand it, if I understand it correctly. And then we submit the transaction and we get the result. And then when you are the recipient, you need to consume the node for the transaction to actually finish. So here is a helper function for consuming the nodes. We can use the client to get all the consumable node IDs, or the IDs of all the consumable nodes, and then we basically create a new transaction with all the node IDs, and we consume them, and by that we add or subtract, or whatever is the actual action in that node, the balances. Now we can mint the token. We're gonna do that now from the faucet that we control, that we have deployed. And we can create new accounts, new wallets. We have done that. We can deploy faucets. We have done that. And yeah, this is just conversion from account ID string to hex as a helper function. So now let's mint some token. So we have this faucet created, and we're gonna say, I'm gonna say I want 1,000 tokens. I'm gonna hit mint, and once that's done, we should see it here in our portfolio as having 1,000 tokens. I'm not sure. We'll see whether it will actually produce a node that we need to consume, or whether it just mints it directly because we control that faucet here in this particular account. Yeah, not 100% sure, but we'll see. So it's not showing up here. Let me fetch the consumable nodes, and as you can see, I have one consumable node, and that is from my faucet amount plus 1,000, and I am the recipient. Which I have no clue what this number is, because it's not this number. So sorry, what this address is, because it's not. So there is multiple identifiers of the accounts, and this is like part of my confusion right now, is like, what is the actual identifier that I'm supposed to use? But
Is there like an
we'll
address
figure it
and
out.
then a shielded address, or something like that? Like, we don't
There
know.
is also an official, like, public faucet. Yeah, here, faucet. And then faucet.testnet.miden.io. And then what they want you to put in is Miden account address. And it is neither of these two. It has a different format. So, like, when you use Miden from CLI, it will give you the account ID and then this address string, which looks different. And that is what you put into that public faucet. So I don't know how to get that public address string, honestly. Like, I have not figured out how to get it from the web client. So maybe someone will answer me later on. I have not asked, to be fair. So let's now, what we can do with this to get it into our portfolio is consume. So we're going to consume all nodes, which basically takes a node and executes it locally in the wallet, in the client, and generates a proof and submits it on chain, which is submits it to my single node blockchain here, running here locally on my laptop. And so once this is done, we will see some amounts in our portfolio, which is great. It still references the faucet ID here. We can check that it's true. It's the same ID. So now we know what this is. Now what I can do is I can actually open another incognito window, go to localhost 3000. As you can see, it's incognito, so there is no history. So I can create new account, deploy account, make it public. Now I have this address or this ID here. So I'm gonna go back. I'm gonna add myself test incognito, put in the address. Now I have this here, and I can send to that address. So I'm gonna use which faucet do I want to do, which account do I want to send to. So it's the test incognito and I can say I want to send one token, and I'm not doing it as a private transaction. I'm doing it as a public, because if I do it as a private transaction, at this point in this UI, there is no way to extract the node. So I have no way how to transfer that information to the recipient. But if it's public, which it is now, it will automatically show up because it's then stored on that RPC node on the blockchain, basically. So once this transaction is executed and sent, we will go to the other window, and obviously we don't see anything in the portfolio because the node has not been consumed. So I'm going to select the account. I'm going to refresh my nodes. So now it's fetching nodes from the blockchain or from the RPC node. And you can see that I have incoming one token from this faucet ID. So that's exactly what I expected. I can consume the node, and what should happen is that it shows up in my portfolio, and that's it, basically, right?
And just like that, that's how quickly things can change, folks. That is how quickly things can change. Let's see what is happening. Please pardon the interruption. You have been watching Václav, the Waku solutions engineer. I heard a beep, and you should be joining us once again. Welcome back.
Chrome crashed. I think Miden is just too much for my Chrome while still streaming.
Okay.
But we'll see. We'll see.
As you share your screen, perhaps cut your camera. I will do the same, and that might save the resources.
Maybe. I'm not 100% sure, but we'll see. So we still have this one here, but we lost the one into incognito window, obviously. I don't know where it got cut off, but I assume that before we actually saw the funds to land there. So test incognito 2. I'm going to create a new account. Okay, I'm going to take the address, put it into my address book again. And then try to send one more token, and hopefully this time it actually won't crash.
That'll definitely work.
I mean, if it does crash, then I guess we need to figure out some other thing. Okay, now let's fetch here. Let's select the account, refresh the nodes, and consume. And again, as I said, this is now generating zero knowledge proofs and executing stuff locally. And when we talked to Miden, they basically said that their wallets will be different than a traditional EVM wallet, where the EVM wallet is very light, while theirs will be a bit beefier and consuming more resources, because a lot of execution, a lot of computation actually happens on the client, which we have just seen with my browser crashing, probably due to some overload somewhere. Okay, so now we can see that we have one token from that faucet address. So this is all good and amazing, and we love it. But the problem is, what about the private nodes, right? So when I select this privacy mode here, what happens is that it generates it actually generates this node, but it does not upload it anywhere, right? And so what we would like to do is we would like to use Waku to actually take care of that. So hopefully, oh yeah, this is gone. Never mind, because I'm not logged in with my MetaMask probably. So, but it's okay. So the next step now would be to obviously include Waku into this code. And the first thing to do then would probably be to improve this address book or change this address book and add one field where basically we would have some human readable name, the address, and then some public key that we can use for encryption and for kind of addressing the user, right? So the way Waku works, if you are regular kind of person coming to these live streams and spaces, Waku is a pub/sub decentralized peer-to-peer pub/sub system. So there are publishers, subscribers, and there's a topic where they publish and subscribe to. So we need to figure out where to subscribe our users so that they can exchange some information, and then so that the senders know where to publish, to what topic, and what information, so that the subscriber can take it and do something with it. So we want to improve the address book so that we can use it. We can use the information there also for encryption. So I think what we could start with is first, because that exchange of information would basically not necessarily need Waku itself, because we will do the exchange of the addresses kind of out of band. And so we're gonna do public key here, which will be sorry, we need to update this type, which will be a public key derived from some private key that we generate and store locally just for the encryption purposes. So here we have public key and default is empty. If new contact, new address, and well, we don't need the public key always, so we can keep it like this. And then we need another input, so we're just gonna copy this, put it here, and then set new contact, public key, e-target value, public key class name. That should generally stay the same. I did not save it. Okay, and maybe let's split it if possible. I don't know what's gonna happen. That's not great. What I'm trying to do is just to make it good. It's even worse. Flex get class name flex row, I think, maybe. No.
Surely the AI knows cursor or knows Flexbox.
Oh yeah, for sure. I don't know why it's not. Yeah, this is kind of what I wanted. Just not it completely. Anyway, as you can see, my new contact, yeah, my designing skills are just bad, and so let me try to pull up Copilot can we make the inputs for address book entries so that the contact name and address are on one row and public key on the next row, taking full width. Okay. We should be able to just apply the changes, hopefully, and then we can figure out. Basically, we need to take a look at how the account is created, and as part of the account creation, we will also generate. Yeah, that's okay. We can leave it like this. We can also generate the private key that we talk about. I mean, there is probably a private key generated. I mean, there is definitely a private key generated, but I don't know what type, and it's gonna be part of the Miden wallet and all that stuff. So I don't want to reuse or abuse it. I just want to make sure that we have a private key that we can use for the encryption of the messages that go over Waku eventually. So now we want to deploy account. Okay, so this is where the account is created. So we also want to make sure that we store, so that we generate the public key. So what I'm gonna do now is I'm gonna install dispatcher pnpm install Waku dispatcher, which is a library that I wrote for using Waku in browser. So it leverages JS Waku, but it abstracts away some of the protocols so that we don't have to really think about them when we are building stuff, or at least when I'm building stuff. Now we are working towards actually having that as part of Waku SDK. These abstractions and making sure that people don't have to fully understand all the protocols that are there to make Waku work reliably and in performant way. So hopefully, eventually, I can just sunset dispatcher and use Waku itself for this. Now I need to figure out how to generate private key, generate key pair, prime. Let me check one thing maybe very quickly. Where was I using this? There is a function, there is a helper function in Waku which allows you to generate the key, and I think I was using it somewhere, but I can't remember where it was, which is usually the problem with all these different projects that I'm randomly working on. I think it's in the Waku utils. So let's see if we have it installed as part of the dispatcher. We don't, but we could install it probably. npm install Waku utils. Okay. That looks good. And then the function we are looking for may no longer be there. Or maybe it was a completely different. It's probably okay. I'm probably confused. Why would it be utils? Why not message encryption? That would make more sense, I think. Okay. And let's try generate private key. Yes. So we're gonna do generate private key, which should return the key, const private key. And so we will also need to figure out how to make a public key from there. I think that there is a function for that. Get public key. Sure. Private key. Okay. What does it, how does it work? Yeah, so it takes the private key and it gives us public key. That makes sense. Const public key. Okay. So that's good. And then we need to have the public key here, obviously, in the address book. I'm not entirely sure what this will result in, but we'll see. We can change it if it breaks. And then also we want to store it in the local storage. So in a stupid, complete hacky way, I'm just going to store it. It would be ideal to do it in a better way, but that's what we get right now. Private key to string. Okay, I think this is not gonna really work. I think we need to make it hex at least or something. But we can try. Worst case scenario, it doesn't work.
It's definitely gonna work.
Stop it, Chair. Whenever you say it, something breaks or like blows up or whatever. So we can just try to create. I'm just gonna do it actually in this incognito window. So incognito window because that's easy to clean up. So test2. I'm just gonna open my console to see the errors immediately when they pop up. Deploy. And the account is there. Let's take a look. I mean, this is really small. Yeah, so I don't know if I can make this bigger. I probably can't. So here, something you cannot really see because it's tiny and also at the bottom of the screen and covered with our beautiful black boxes instead of our faces, is something that we have the information that we have tried to kind of store. So there is an account ID, whether the account is public, private key, public key. I mean, it's tiny, but it's okay.
I think you can zoom in if you click on the dev tools itself and then Control Plus.
No, I tried.
No,
I tried.
Oh, okay.
I was Control Plusing like crazy for a bit, but it didn't do anything. Now for the address book, we have the test tool. We don't have the public key displayed, so we need to add that as well. So address book and we can just really ask, can you add the public key to the address listing as well? Okay, so that's doing something. Oh man, I hate how huge it is. Okay. Let's apply it. And so now we would have the information we potentially need to send the stuff. Yeah, this is not ideal, but it's okay. We can live with that. We will need to change it to hex eventually. Fine. So now, assuming that when we created this one, so we can kind of take this and put it into another address book of another account. So now we need to plug in the Waku itself. So I'm going to create a new file here, Waku client.ts, and we will want to have an async get Waku or get dispatcher maybe. I don't know. What am I doing? Const get dispatcher. I think here we want dispatcher. So if not initialized, I don't want that. I want const initialized equals false. If not initialized, then we want to const the new dispatcher, and so we will let it just create the node content topic. We're gonna select something like Waku v2. That's not what I wanted. Waku 2. How does the content topic look like? It's something like Miden POC UI version 1 and what else?
Exclaim.
Accounts. I don't know. JSON, because we're gonna use JSON. What else? Ephemeral no, false. And we need to store, so I'm just also gonna do store new store from dispatcher, and that has a name, so that will be Miden Waku, and do S here. We need to create the node. Okay, I did not see that. Why do we have to create a node? We shouldn't need to. Okay, so let's change this a bit. There is another way. D equals await get dispatcher and what? Ah, okay. Get client get dispatcher, and so we can do undefined here. Content topic we just move from here. What else? This will be Waku Miden, ephemeral false, auto start true, and bootstrap nodes we don't need. Okay, we don't need this then, and then we can say initialize true. We want to do it first probably. And then we want this picture. Okay, so here we should have the dispatcher initialized in theory. I mean, very basic initialization. We need a bit more. So we need, well, if not dispatcher, then throw an error. That's fair. And then we also want to do dispatcher on. So we will want to listen for some messages. So when someone sends a note, we need to know that there is a Waku message on this content topic, and that we want to process it, and what type of message it is. And there are different ways of doing this. Dispatcher has it as you specify the type as a string, so it's gonna be basically just a note, maybe. And then there is this callback, where you actually execute what happens. Now this callback needs to be async, and I think it should also potentially want more information. It doesn't. We'll see. We'll see how that goes. And I think that we can also specify a few more things. So we don't want to verify the sender because we will not have Ethereum wallet address. Dispatcher only understands EVM addresses. So we want to verify sender false. Exit only encrypted, I think is going to be true. And that's it. We also need to make sure that we kind of register the key. So we will want to pass the key here. I'm just going to set it as any. So then dispatcher has this method called register key. And then the key will be key. And the key type, we will have we will use asymmetric. So this will be our private key. And so the type is going to be actually the uint 8 array. And now I think that should be mostly it. We have set it to auto start, so now we don't need to. And what else? We may want to do the query, dispatch query, and we probably can do with default. So what this does is that queries a store protocol of Waku for last an hour of messages and tries to process them basically. So if there are nodes that are supposed to be delivered, but we were offline, this would query Waku. I think that's it, kind of. I'm going to rename this to initialize dispatcher, and we're going to try to call it somewhere relatively early on. Set is client true, saved accounts, local storage set item, deploy accounts. I'm just trying to figure out where would be a good place to kind of initialize all of this. I would say basically as early as possible. So maybe somewhere in the layout even. Client layout. It's a component. Public key display, use wallet. I'm not sure I've seen this anywhere. Interesting. No, Miden wallet. I have not seen where this is used. There's no way to connect a wallet. Anyway, maybe let's just go here and let's just call initialize. I did not export it, right? Waku client. Export. Initialize dispatcher. And we need the key, so we have to do it actually elsewhere. And it has to happen with account management. Now I know. So whenever we select an account, so let's figure out set selected account. Okay, set selected account. Is there any kind of use effect? It's not, but it's okay. We can add it. So use set new account. Set. Where is this called? Set selected account. Okay, so here, so here we need to do new use effect, and then basically figure this out. So we will need to fetch the account account private key. So local storage dot get item. I'm just gonna remove this for now. And what was the way we stored it when we created it? It was like this. So we need that again, and that would be the selected account. In theory. And we would like to do const info if account info JSON parse account info private key. I'm not sure if this actually is gonna work, but we can try. Yes, that's good. And so maybe if we reload and select an account, something will actually happen. So here you can see that it actually works, surprisingly. And so Waku is starting. You can see the error warning, ignore WebSocket connection failures. Waku tries to discover peers, and some of them are expected to fail, which is fair. And now here, in a very tiny font, it says query done, and that's a dispatcher's message telling us that it actually successfully queried the store protocol. So now Waku is connected, and it's regularly, apart from like listening for new messages, it's also regularly querying store protocol to make sure that it does not miss any message. Dispatcher is querying that. So I think that's a good first step. So now basically when we select this test2 account, it used the private key to register it as a decryption key for messages. And if there is a new message, it would expect it to be encrypted with this public key. And Yeah, and that's it. And then if someone sends us a note, we would get it and be able to hopefully decrypt it. So now we are what, an hour in, right? So what we could try to do is we could try to mock basically some custom node. So like if we do this send and we hit the send for this address book test 2, it would take that public key, it would encrypt some message. It doesn't have to be the node, because I don't think that we can get the private nodes working fully here. But it would encrypt some message, which can be just hello world, and it would send it, and we should be able to receive it and display it, or do something. Now we are kind of in a chat again, but like, as I said multiple times, everything is a chat eventually, because as soon as you start communicating between multiple instances or multiple components of your application, it's just a chat. It's just, what is the payload, and what is the encryption scheme, and what is the actual, is it a one-to-one, or is it a group chat, or is it a public broadcast? But usually you can just think about everything as a chat. So we can just build a kind of a chat module into this, where the content of the payload of the chat message is the actual node. And we are using this address book as a way um, to address stuff and to encrypt and decrypt things. If I don't see in comments any questions, any
Nothing
suggestions, any
specific.
complaints. Yeah, so if you have anything that is not clear or is clear, and I'm just doing weird stuff, please do let me know. Um, yeah, sure. You made a noise like you want to say something. Please do say something so that I can stop talking.
Well, the chat is open, folks. If you have any queries about what you have just seen and experienced, Václav hacking together Waku and Miden, please drop them in the chat or in the comments on Twitter or YouTube. If you're interested in learning more about Waku, waku.org. Václav, back to you.
Thank you. So just looking at the code for the send section. So now what we will want to do is probably to add there a way to send something, whatever that something is, send something once we actually finalize sending the transaction, which basically also means finalize creating the node. So handle send was going to be our function of choice for that. Is sending account ID with this transaction information. We're calling batch transfer, and then basically if it actually succeeds, we push out this node. I consumed is the right word here, but basically this success toast. So what we could do, we could just send the transaction ID to the other participant. I think that's a good start. If we can actually successfully send the transaction ID from one account to another over Waku, we can definitely send a node once we are able to extract it from this whole web client thing, which I was not able to right before the stream. So that's also partially why I'm trying to avoid doing that. Okay, so basically here on the success, or after the success, what we could do is we could const dispatcher await initialize. Actually, let me go back to this Waku client, and let's just do export const get this picture and just Oh. Whatever. Don't look at me like I'm doing really crazy stuff. I am doing really crazy stuff. Okay. So we're gonna
Wacky,
assume.
wild stuff.
Yeah, I mean, we're gonna assume that this picture is initialized kind of here at this point. So it may not be. That's something to handle. And so this is obviously nonsense. That's not how this picture works. So dispatcher.emit. Emit is the function that we use to push a message. We need to have that type. So I should probably just make it an actual const here. Message type equals note. Message type. And then where was I? Here. We can do message. I did not export it again. So can I export it? Message type. And then the payload is just, I'm just gonna do string, and it's gonna be the transaction ID, like this. Although it may be better to just do it as an object. So it's gonna be text ID, no wallet, but we need that encryption key, so that public key from the recipient. And so the question is, how do we actually get that here? So when we select the recipient, input update recipient, on change index amount, and then value. No, it's not. Select from address book. It's probably address book. What is this? Recipients, show address book. Recipient. Okay. Okay, let me go here because I have the faucet here. And so here we have the recipients. How do I actually add the public key? So address book does not have the information I was hoping it would have. I thought that we added public key to we added public key to contact. So now this should actually send can be what? So we should, in theory, have the address book, have the public key in the address book. So when we select here the contact, select from address book, we should be able to update the recipient type, wherever that is. Here, recipient public key string. Okay. Send. Add recipient. Okay. And now okay. And we want to make sure that the select from address book actually field address amount actually also has the update for the public key. Okay, so we want to just copy this, I think. And the public key and the public key string, public key. This should be handled differently for sure. But we are just hacking here. So there is no reason. Why is it?
Just a couple of guys hacking. Just
Why does
dudes
it
being
not?
dudes.
Yeah, why does it not have the? Ah, it's a different type. Why is it a different type? Someone was hacking this for sure. Recipient. Okay, no, that should be way better. Contact. No, not recipient. Damn it. Wrong. It's contact. Contact. Okay, like this. So now we should have public key, and we should be able to here say, well, the recipient is an array, so we would have to basically do it for all the recipients, I guess. Let's just hack it in a way that we just assume that there's just one. And we need to turn this into uint array. I think we said that this is not going to work, and it's not going to work. This is recipients. Can you help? Can you help me convert public key string to uint array? I'm definitely not a JavaScript developer, although I pretend to be. So, whoa, interesting. Not convert public key. It is from. What does it take? Array like. Oh, okay. I have no clue what this does. Public
Can you
key.
repeat what the query was?
The query was to convert the string. So the public key, we stored it as a string, and we stored it as a completely shitty string. Basically, just a serialized array, which I think is a terrible idea and probably not going to work. I'm just complicating my own life here. I was just curious what is like came up with this solution in a sense that like it will take every two characters and convert it to number, and I don't think that makes any sense. So we should probably just fix this first So here, the private key and public key. Can we convert the private key and public key to hex? Instead of just stringifying the array. And this should be better, probably. Yeah, makes more sense. It's kind of what I was thinking about, but I was too lazy to type it, and then AI decided to do it in a more lame way. And then we need to convert it back in send for public key. No, this is not. That's weird. Split the hex string into pair. Okay. Now it kind of makes sense. But I also feel like there should be a better way. But I don't know. Let's just do it. We'll see. Maybe it's gonna work. Maybe not. Don't laugh at me. If you're laughing, then you can try hacking on live stream.
Nobody's laughing. We are with you.
No. I would be laughing. Like, oh, this dude. Okay, so now this basically what should happen, and I hope that it is gonna happen. What should happen is that when we actually finish this, transaction info sent successfully. This is not actually right because this returns boolean, so we need to check that. Otherwise, it doesn't make any sense. If result, not result. Yeah. Okay. So what I'm gonna try to do, I guess, is actually send something. Await has no effect. Okay, that's fair. Given that we assume it's initialized, which may not be. I'm just gonna try it. So first of all, I'm gonna close this, and I'm gonna start fresh again. Specifically because I need to make sure that the private and public key are stored in the way we want them to be stored. So now if I look at the address book, it still looks wrong. Okay, why does it look wrong? Oh, this is actually correct representation, the hex. Why did it actually do this? Set deploy, set address book. Right, we did not do it properly here. So that should not have a big impact on anything because it's stored in the local storage in the way we need it. So this is more about the display. So now we have one account. We need a second account. So I'm just going to do two. Just let me close this. Deploy another account. I'm going to create faucet for that one account and send funds to another account. So now this public key looks a bit better, easier to copy, easier to share around if we actually wanted to do it. So I'm going to select incognito 1. I'm going to create a faucet. Let's do Waku, deploy faucet. Fingers crossed it's not going to completely fail. We have 8 minutes, so we can send one message I would be very, very excited for that. Yeah, chair has been
We're
privately
definitely gonna do it.
we don't have time, and I was ignoring it because I was just too focused. But now we have only a bit of time. But I think that we may actually be able to publish a message. Oops. if if it actually works. Okay. Oh yeah. So it can only have uppercase characters. Took very long to tell me that I have a unallowed characters in the faucet name. Interesting. Okay, so now we have this, so we can mint some amount. I'm gonna do just 100 mint tokens. I'm minting it into the incognito 1 account, and I'm gonna send it to incognito 2, and I'm gonna check if there is a message received. And the way I hopefully see that, so send faucet Waku incognito 2 amount 1, is that I should hopefully see something in the console or some toast saying something. Failed to create a transaction subtracting 1 from a fungible asset. Oh, I didn't consume the nodes. Sorry. So let me fix that. I forgot to consume my mint node. Consuming nodes, sending transactions. Come on, come on. Do something. If it crashes, I'm not gonna turn the live stream on again.
That'll be
And
a
we can also-
graceful out.
And I can also pretend it crashed, right?
Indeed.
Yeah. Come on, work.
It's gonna work through collective prayer. Boom.
Nope.
Something. No?
Nope. Still consuming. It's not hungry enough.
Well, folks, if you're joining us late, you can find the replay just as soon as we conclude, both here on X and YouTube. We appreciate your likes and shares, follows, and subscription. You have been watching Václav, Waku Solutions Engineer, Hack with Waku and 0xMiden. And as we await the success of this message sending.
Okay, so we have the tokens. So I'm gonna try to hit the send again. And what we want to see is we want to see that the transaction actually happens, and then a Waku message is sent. So there should hopefully be a toast notification about that, or something in the console, which you can't really see that much, but I'll tell you if there is something interesting. Sending the transaction. It's tense. So basically what happens after, like, regardless of whether it works or not, nodes consumed successfully, and the message was sent. Here you can see, if you can see, that there is a message, failed to decrypt the message. It is tiny, but there are some weird characters. Maybe you can make something out of it. And so why that is that currently the Waku dispatcher is configured for this incognito 1 account. We would want it to now switch it to incognito 2, and basically get that message and decrypt it. Maybe it would work, but I'm not gonna try right now. So my next step. So now we know that like when we actually do the transaction, we can publish a message on Waku with some content. Right now, that's just transaction ID. Ideally, that would be an actual node. And then when we have another account following with the right private key, we would decrypt that and process the node import it into our local wallet, and then we can consume it. So given that we are out of time, and also I'm out of brain power right now, it's very tiring to talk and do stuff and actually think about what you're doing. So what I'm gonna do is I'm gonna try to continue hacking on this tomorrow and maybe Friday to actually get it into a working state, send a PR to this Miden POCY and record a demo of it. So hopefully by the end of the week, I will have a demo that actually involves the actual node and the consumption of actual node. Maybe not, but hopefully it will be there. Yeah, so still, if you have questions, if you have thoughts about what you just saw, what just happened, anything you want to know or you think you know or you don't know, I'm always happy to answer online or like publicly or in DMs. Doesn't really matter. But yeah, I'm done here, chair. I'm drained. There's
Vaslav,
nothing
thank
else.
you very much for taking us through it. Folks, if you like what you saw or are interested in learning more, waku.org, as you can see there scrolling at the bottom of the screen. Vaslav, thank you very, very much. And look forward to a follow up. We'll check in and
Thanks
see
everyone
how long
for
we got.
sticking around. I know this was not as cool as hacking Trollbox, which I did last time, but maybe next time.
There is always next time. This has been the Waku Vibe coding session. We will see you all very, very soon. Thank you, Vaslav.
Thank you, Chair.